In this lesson, we're going to continue with the topic of quadratics and look at intersection of lines and parabolas. So, if we have a line and a parabola, the line may intersect the parabola twice. It may touch it once, i.e. it's a tangent to the parabola, or it might not intersect the parabola at all. So if we have a line with equation of the form y equals mx plus k, and we've got a parabola with equation of the form y equals px squared plus qx plus r, equating would give us mx plus k equals px squared plus qx plus r. If we collect like theorems basically, and we subtract our mx and subtract our k from both sides of the equation, we get px squared plus qx minus mx plus r minus k equals 0. And then we can take out, for instance, a common factor of x between these two terms. So we can see we've got px squared plus q minus m multiplied by x plus r minus k equals 0. And what we actually have now is a quadratic equation. We've got an x squared term, got an x term here, and we've got a constant being equal to 0. So we've actually got this quadratic equation, and hence we can conclude that if the discriminant of this quadratic equation is greater than 0, then the line meets the parabola at two distinct points. So it's quite similar to the thinking about the discriminant and what it tells us about quadratic equations on their own. It tells us the nature of that quadratic equation and about the roots that it has, and you can see why this is related here. So if the discriminant is greater than 0, it means the line meets the parabola at two distinct points. If the discriminant is equal to 0, then it means that the line meets the parabola once, i.e. the line is a tangent to the parabola. And finally, if b squared minus 4ac, the discriminant, is less than 0, then it means that the line does not meet the parabola at all. So let's maybe look at an example. So example 1 asks us to find the coordinates of the points where the line with equation y equals 2x plus 1 intersects the curve with equation y equals x squared minus 2. So we first need to equate these. We can see that they are both y equals, so that allows us to equate the equation of the line and the equation of the curve. So we have 2x plus 1 equals x squared minus 2. Now, we can subtract our 2x and our 1 from both sides of the equation, and that will give us x squared minus 2x minus 3 equals 0. We can then factorise this because we need to solve for x, and that will be when we solve for x, that will give us the x coordinates of these points where these points of intersection. So factorising gives us x minus 3, x plus 1 equals 0. And using the null factor theorem, we know that x minus 3 is equal to 0, or x plus 1 is equal to 0. Solving gives us x equal to 3 and x equal to negative 1. Now those are our x ordinates of the points, but we want to find the y ordinates so that we've got the full coordinates of the points. So when x is equal to 3, we can substitute into one of the original equations. Probably here the straight line equation might be easier, but it's up to you which one you use. Both will give you the same answer. So when x is equal to 3, we can calculate y, we're saying 2 times 3 plus 1, that's using the straight line equation, gives us 7. So we have the point 3, 7. And when x is equal to negative 1, y will be 2 times negative 1 plus 1, which is also negative 1. So we have these 2 points, 3, 7 and negative 1, negative 1. And those are the points of intersection where that line meets the parabola. And we can just check that using a graph. So the purple line here is y equals 2x plus 1, and the red curve is y equals x squared minus 2. And you can see these 2 points that we have calculated are occurring here. That's the points of intersection. So just now would be a good time to pause the video before the second example and take this one down in your notes. So example 2 then, show that the line with equation y equals 5x minus 2 is a tangent to the parabola y equals 2x squared plus x, and find the point of contact. So we know from the last example that we can equate these because we have y equals for both of them. So that means that 5x minus 2 is equal to 2x squared plus x. Now subtracting the 5x from both sides and adding my 2 will give me 2x squared minus 4x plus 2 equals 0. Now, obviously I need to solve for x here, but I'm noticing that there's a common factor of 2 here, so I'm going to divide by 2 firstly to make the factorisation easier. So dividing by 2 leaves me with x squared minus 2x plus 1 equals 0. And if I factorise this, I get x minus 1 all squared equals 0. Now here I have a repeated root. So when I have a repeated root, that's the equivalent of b squared minus 4ac, the discriminant, being equal to 0. So that means that we have a tangent. So a repeated root implies tangency. So we have now shown that the line is a tangent to the parabola, and we now need to find the point of contact. So we know that solving x minus 1 all squared equals 0 gives us x equals 1. We then need to find our y ordinate. So substituting into one of our original equations, I am choosing the straight line again here. 5 multiplied by 1 is 5, minus 2 gives me 3. So the point of contact is 1, 3. Now, obviously here I pointed out that the repeated root implies tangency. I could actually, here on this line where it says x squared minus 2x plus 1 equals 0, I could have examined my discriminant at that point. So the discriminant would be negative 2 all squared minus 4 multiplied by 1 multiplied by 1, and that gives me 0. Therefore, the line is a tangent to the parabola. But then you would continue this same working. So in actual fact, just showing that it's a repeated root and saying that that implies tangency is actually slightly less work than having to work with the discriminant as well. And finally, before you copy this down, we'll just have a wee look at the graph here. So the black curve is obviously the parabola with equation y equals 2x squared plus x, and the purple line is the line with equation y equals 5x minus 2. And you can see the tangent here, that the line is a tangent to the curve, and it meets at the point 1, 3. So just now would be a good time to pause the video and copy this down in your notes.